everyone. Today we have our another new episode, and we will discuss about space exploration with solar systems, sun, and spaceships. We have our world famous speaker, Professor Ching, Mr. Anthony, Mr. Adam, and Professor Ram. First, I would like to give chance Professor Ching.
Uh, yes. Uh, well, I have just written my first project on survival. Okay, basically, survival includes human survival. Okay, basically, let's start with individual survival, human survival, and universe survival. In other words, there's three stages. Human, us, we need to survive. Okay. Then there's the human race that must survive. Then we go to, which is probably not none of our business now. We are so backward in knowledge. The universe, how the universe survival. So in other words, I'm starting from now, in my life, I will only study this one subject, survival. Okay, this is I would challenge people to come up with an even more important topic. Okay, so in order to survive, we have to survive through all these crises: financial crisis, health crisis, environmental crisis, all kinds of crises which challenge or survival crisis itself, cultural crisis. So this sounds solar system, sun and planet. It's related to the human survival. Okay. It involve individual too. So let's start with individual survival. Okay. The three most important things in survival is air. When I was young, I breathed air. I thought it's natural. But now, when I grow older, I feel that the pollution, air pollution, is stopping human beings from going beyond the lifespan of 80. Okay. You have to have, all the people live to 90 or more. I see them living in a very clean air environment. Okay. So this pollution is terrible. It's in food, in water, in air, okay, mostly in air. So I would this is already advice. If you want to grow old over 90, you try to pick a place where there's clean air. Okay. So this is individual survival, but today we are talking about the human survival. We're talking about subject related to mostly to human survival. And where the Earth will stay on its orbit. Okay, first we got to have a stable Earth. Okay, the Earth will stay on its orbit according to some kind of very rough simulation. Actually, it's very accurate. They claim to be the best. It will be 150 million years. The Earth will going around the sun in a stable orbit. Okay, this kind of calculation is done by top mathematicians throughout history. Okay, but now we have computer. They did this study, and this just give you a rough figure. It's in the order of 100 million years. But that's not the limiting factor. Okay, the limiting factor is the environment. Okay, it's the weather. Okay, there is a cycle, ice age cycle. Okay, this guy, Serbian scientist Milakovic, he looked at the geography, and he found that it's so stable. Okay, the ice age cycle is so stable. It's going to happen. Okay, so the cycle, I roughly estimate it would be from 20 to 40,000 years. There will be a cycle coming. Okay, so we need to worry about that. This is mainly because the Earth's tilting. Okay, all Earth's orbit tilt on its axis, every 40,000 years. So the weather pattern comes. So each human species. We have many Neanderthal and all this past human species. Each had 40,000 years to, to advance their knowledge enough so they can survive. But they didn't survive. Okay. We going to survive? Okay. Today we're worried about this all this global warming. Okay. At least we have made a dent on Earth's environment. Okay. It's everyone claims it's bad. Okay. But in the past, human species cannot even make a dent. Okay. And the weather pattern was so regular that nobody can affect us. At least we have something you know that show that we can affect the Earth's environment. But we need to eventually in 40,000 years, within roughly 20 to 40,000, we need to be able to affect in a in a in a beneficial way, not in an adverse way. Today, actually, it's not adverse; it's just random. Okay, we just burn a lot of coal, a lot of fossil fuel, and we cause this environmental crisis, which seems to be a crisis, but humans is nothing compared to nature. Okay? Nature can put it. Okay, the nature crisis actually the one of the according to some overall survey of the Earth's condition, they think earthquake is the biggest problem. Okay. Once the earthquake suddenly explode, it can but earthquake is so irregular, you cannot really count on in the survival discussion. Okay, in a survival discussion, it's the weather pattern. Okay, my own feeling is the Earth is so well organized. I really suspect it could be designed. Okay, and also from my study of fuzzy logic, I find why is the reality fuzzy? The reason is nothing. We can solve nothing. Okay. All we can do is solve it fuzzily. We solve it just part of it. We can never solve a problem perfectly. We must make compromises and just do our best to survive. Okay. So this on Earth, everything is set up so nice. I go to clubs in San Francisco, all these people are so happy, like nothing, the world is going on, you know, it's natural. It's not natural. Okay. The universe is such a hostile place. Okay, even on Earth, we see from fuzzy logic, nothing has been solved perfectly. Okay, the scientists give a completely total wrong impression. It's a fallacy that everything can be solved exactly. Exact is a word that it cannot be applied to reality. And the scientist has this obsession on perception, on position. So this is a total contradiction. Okay, so I suspect that the solar system is so well organized. For example, the moon is necessary to stir up the ocean. Suppose we don't have the moon, we don't have tides. Okay, the animals on the shore cannot be fed by tidal, nutrition coming from the tide. Okay, it's necessary to stir up the ocean. The moon is necessary to stir up the ocean. And also the weather. We have 4 seasons. You see, if you look at some picture, I think many of you probably also see this. You see the weather pattern throughout the years of the year. Every year we have pollution, then the weather, the storms blow it out, clean it up. Then we build up another polluted earth. Okay, it's just like the pollution problem is not that we do it once. We accumulate the pollution. Okay, every year it gets more and more pollution come in. Okay, and this weather seasons they help clean out every year. Every year through these 4 seasons. So things looks suspiciously, too regular. Okay, basically that's the Earth, and also other planets. They might also have some kind of things similar, but the Earth seems to be the planet that is chosen, and there's so much design going into this. It seems like, I suspect, it seems like, but it doesn't matter what I think. You see, the importance is that we have about 20 to 40 years to get our act together. Okay, to advance, basically by advancing knowledge. Today we are able to, we seem that this is seem to be the first human species which can make some dent on the earth, on nature. Okay. In the past, nothing changes. So when they did survey, min, for a few thousand years, it looks like it's so regular. The nature just going on its business. Nobody can affect it. So we need to sort of think in these terms. Okay, start from individual survival to human survival, which is related to our today's subject, and then finally to universal survival, where I don't think we can participate in this. We just cannot even get our human survival and individual survival right. You see, so basically that is what my initial feeling about the
Thank
solar.
you.
Okay.
Thank you, Professor. Thank you,
Yes,
Professor.
in connection with Professor Ching, I think he made
Yeah.
some wonderful points there. The
Yeah.
beauty of
Thanks.
the cosmos,
Yeah.
the
Thanks.
intricate design and the balance that we see within the cosmos itself, taking our solar system into consideration, parallel to an atomic structure. The sun, a giant ball of fire, twisting and turning in the magnetic fields of its own creation. Everything, as far as I'm concerned, connects to, I'm a theistic evolutionist. So that I know I'll probably upset a lot of atheists, but I'm a theistic evolutionist. But everything within the cosmos indicates a higher power at play within evolution and in the cosmos itself. As we go deeper and study more astrophysics, cosmology, and so forth, it certainly indicates that there is a higher power at play. Now, in terms of what Tim was saying about the moon, I mean, the moon actually takes enormous amounts of tidal stresses as a result of this symbiotic gravitational interplay with Earth. Obviously, we have tidal stresses on Earth, high tide, low tide, but the moon also has tidal stresses. Now, you don't need water to have tidal stresses. What you get is unbalanced stresses on the moon. Now, these unbalanced stresses on the moon are very harsh, considering that the Earth is 80 times the mass of the moon. And these unbalanced stresses on the moon generate lunar quakes. Now, these lunar quakes can actually last up to an hour. And the reason why they can last so long is because there's no water to dampen seismic vibrations. Anyway, now I'm going to sort of do a quantum leap. Mars. In connection with my last book, Mars was formed 4.5 billion years ago inside a solar nebula. Inside a solar nebula. Now, in terms of Mars, this is the most terraformable planet. We can produce electricity on Mars once we create a greenhouse effect and create an atmosphere on Mars through electrolysis. DC current through a water solution. You separate oxygen atoms from hydrogen atoms. You pump hydrogen into a fuel cell, recombine with oxygen, you produce electricity. Not to mention, because Mars is full of iron oxide, the reason why the planet is red is because of iron oxide. Through iron oxide, we can create steel. We can produce glass. We can produce plastics. So everything, there is a lot there that we can use to produce things like steel, glass, and plastics as a result of iron oxide. So it's a very important point. Now, in terms of actually terraforming Mars, interestingly, the distance between Earth and Mars is variable due to their elliptical orbits around the Sun. At their closest point, they're separated by a distance of 57 million kilometers, and at the furthest point, they're separated by a distance of 401 million kilometers. So there's a massive difference in terms of distance. It's variable due to their elliptical orbits and so forth. Now, some of the problems about terraforming Mars arise as a result of the lack of a magnetosphere. Mars's magnetosphere was wiped out as a result of the slowing of its magnetic core, its iron core. So it lacks a magnetosphere, meaning that the planet is subjected to enormous amounts of cosmic radiation, gamma rays, ultraviolet light from supernova, neutron stars, and pulsars. So the planet is bombarded with enormous amounts of cosmic radiation. As a result, of its lack of a magnetosphere that was wiped out as a result of the slowing of its magnetic core. So this is a huge problem that we need to consider if we're going to terraform. So we're talking about highly energetic particles that can bring on cancers and all sorts of health conditions. One of the ways to bypass this problem would be to build domes from special alloys that have the ability to repel lethal cosmic radiation, or to have underground bases. Okay, this could be a way we could deal with it. Another problem is that once we create an atmosphere on Mars through the greenhouse effect, importation of hydrocarbons like ammonia, methane, and so forth, orbital mirrors, which maximize sunlight absorption, reducing the planet's albedo, which means reducing the amount of sunlight that is reflected back out into space. So through orbital mirrors, we can maximize sunlight absorption, heat the planet, and through the importation of hydrocarbons, methane, and ammonia, we can create a greenhouse effect and produce an atmosphere that is human-friendly. Of course, we can also use the fact of redirecting asteroids and comets to strike into its surface to release carbon dioxide into the atmosphere. The planet is predominantly carbon dioxide, 95% carbon dioxide, 3% nitrogen, 1.6 argon, with minimal traces of water and oxygen. So through the greenhouse effect, we can create an atmosphere on Mars. But the problem is that Mars's gravitational field is not strong enough to retain an atmosphere. Atmosphere and gravity are intercombined. In order to retain an atmosphere, you need a certain gravitational field. Over time, we could lose the atmosphere produced on Mars to outer space as a result of its weak gravitational field. Mars is just under half the size of planet Earth. So these are some of the things that we need to take into consideration. Also, going back to the whole problem of radiation, as I said, these domes ideally would be made from special alloys that had the ability to repel lethal cosmic radiation and so forth. In terms of solar winds, well, solar winds are constantly eating away at Mars's upper atmosphere and ionosphere as we speak. So once we create an atmosphere on Mars, we could have, again, this erosion process, solar winds eating away at the atmosphere produced. So it could slowly eat away at the atmosphere produced. NASA were talking about launching a giant magnetic shield into space, which I've mentioned, before, a giant magnetic shield into space that could nullify some of these solar wind erosion processes. So these are some of the ways we could get around this particular problem of solar winds eating away at the atmosphere. So, yeah, I think I've said quite a bit, so I'm going to pass it on to Adam now, and I'll be back for round two. Thank you.
Thank you. Mr.
Thank
Adam.
you.
Thank you. Hello. Yeah, great topic today, Sharif. It reminds me of one of my favorite quotes spoken or written by Russian space pioneer Tsiolkovsky. Humanity, like the baby, cannot stay in the cradle forever. I know I'm paraphrasing it a bit, but yes, that is a good metaphor, the cradle being a metaphor for the planet Earth, of course. More and more exoplanets are being discovered all the time, every passing year. I'm not sure how many have been found in total by now, exoplanets that is. But several years ago, I always found it quite puzzling that astronomers and astrophysicists and planetologists, that's quite an uncommon, rarely used term now, isn't it? Planetologists, we don't see it much now. But I found it puzzling that people seeking exoplanets limited themselves to Earth-like planets that carried lots of water like ours, because even on Earth, you have classes of life that are extremophiles, where forms of life live and even flourish in environmental conditions that are not ideal for us humans, environments we humans would consider toxic and inhospitable. Perhaps every planet and moon in our solar system has some form of life, on asteroids too, perhaps. And one of Jupiter's moons, Europa, was an important plot device in Arthur C. Clarke's 2001, 2010, etc. Space Odyssey story arc. In 2010 particularly, I think, and in the film, Europa having life that are about to become advanced. And I would bet in real life that Europa actually does hold life as well. And if I'm not mistaken, it's an ocean moon, and the ocean is salty water like ours. Yeah.
I'm going to come around to that next.
Yeah. Oh, excellent. Yeah. Well, it reminds me of the movie The Abyss, unidentified swimming objects and all that. Yeah. But I know it's a bit of a cliche now, but we still know very little about our own oceans here on Earth, especially the deepest depths in the trenches and such. So in
The
terms of
Mariana Trench.
that's the one, yeah, with the bathyscapes and all that. So in terms of exploration, as well as going up, we also need to not forget to go down as well. And I love all the planets and the moons. I love all the different colours and hues and sizes and rings or no rings, and different numbers of moons and satellites. And I also wanted to concur with what Mr. Anthony said. Like him, I'm also a theist, specifically a polytheist or pantheist. It's self-evident to my eyes, in my mind. You just look around, and one of my favourite phrases in Latin is creatio ex nihilo, creation from nothing. It's quite a frightening aphorism because it's a paradox. It's paradoxical, and paradoxes are simultaneously awe-inspiring and terrifying. It's apparent to me that only a higher intelligence can create something out of nothing, create itself out of nothing, even. A paradox again, of course, but still. My mind cannot compute a spontaneous creatio ex nihilo. There must be a living, unmoved mover at the bottom of it all, in my opinion. Yeah, that's what I've got to say so far. Thank you.
Thank you. Professor Rob. Can you unmute, please?
Okay. Well,
All right. Apparently my mute button is stuck. So with regard to space exploration, we have a number of problems with it. First is heavy lift is very expensive. Getting stuff up into space is a problem. And getting stuff down from space, depending on its weight, could be a problem. Asteroid mining would be great, except if we redirected an asteroid to the planet where we could take it apart, it would have to be pretty small, and we'd have to be pretty sure where it landed. Otherwise, it could do a significant amount of damage. Ask the dinosaurs. And people don't do well in space. We weren't designed for it. Our evolution was on a planet with Earth gravity and an oxygen, an atmosphere, and so in space, while nobody can hear you scream, it's not a place, at least for now, that people can live without either genetic modification or an awful lot of shielding and some way to replace the gravity. The supposition is you could put people in space and use a centrifugal force to emulate gravity and solve the problem that way. No real long-term testing to validate that, but that's the current belief for long-term space exploration. Chances are, and of course we've mentioned Mars. Mars is a place that right now we could go to but couldn't come back from. So that would be somewhat problematic for anybody that went. We have had certain experiences with places like Antarctica, where you've got teams that are in place, remote, somebody gets sick, they can't get them out. And a hell of a lot easier to get people out of Antarctica than would be to return them from Mars. So the difficulty really is, when we talk about exploring space, the imagination is we're going to get spaceships and a Star Trek-like experience, and we'll go out and explore. But the reality is probably going to be some type of an automated solution. Machines can handle outer space better than we can. In terms of space mining, at least the current plan of record is to use robotic miners and set up some type of an automated factory to pull out the materials that you needed from the asteroids that you were mining, and then either manufacture those materials and do something with the finished goods with regard to space exploration or a commercial expansion, or somehow figure out a way to drop them to the planet safely. Granted, the atmosphere does give us an option that we don't really have as strong on places like Mars because of its thin atmosphere, and of course it's to use the atmosphere itself as a way to cushion the landing and drop the material back to the planet. But our inability to actually measure the weather very well makes that kind of an iffy prospect as well for anything that is either unautomated or unmanned. So the issues with regard to space exploration near term, in my view, is our expectations about what we can do on our scientific capability of what we are able to do are two very different things at the moment. And our robotic capability, our autonomous robotic capability, while it's advanced significantly in the last 2 decades, is still not to the level that it would need to be to operate in space. In 2001: A Space Odyssey, HAL, the fictional AI that was in the spaceship, was significantly more advanced than anything we can deploy at the moment. So once again, showcasing that science fiction is really good with being able to imagine a future. It just kind of sucks with regard to the timeline for when that future may emerge. We will eventually create AIs that will be able to do that. Hopefully we won't corrupt them in the process. 2001 does also kind of showcase, and I think reasonably accurately, what could happen with an automated system without oversight. In 2001, the AI is corrupted with conflicting commands and effectively goes insane. That's probably somewhat of a stretch, but we know full well that programming will never survive without significant patching over time. We can't anticipate everything. We can do far more today with simulation than we've ever been able to do in the past, but we can't simulate what we've never seen. And much of outer space we haven't seen. In fact, only a tiny fragment of outer space have we seen. And dealing with things like micrometeorites, which we cannot predict or even effectively shield from, given their relativistic speeds, is problematic. And certainly the impact of X-rays and radiation on memory, we know can be significant. It causes degrade over time, which means even an automated system would need to have multiple redundancies, have massive air checking and correction facilities inside, to a far more redundant level than we've ever deployed here on the planet, because we've got an atmosphere that shields from that, and so we don't have to double shield. Even so, we get degradation in our computers even on the ground here. And so the effort to truly explore space and send out probes and then make it commercially viable at this particular point, while we talk a bit about how space exploration has created things like Velcro and has advanced our knowledge, and even in areas like medicine, our true commercialization of space, so it's a truly profitable entity, still resides in our future and probably should be a higher priority. Now, there's a lot of discussion about taking us off planet, but once again, ask the dinosaurs. If you live on a single planet, even if you take care of the planet very well, there's a pretty good chance that something's going to happen, and it's going to wipe out life on the planet. We might be able to shield from some of it in deep mines or in government facilities that have been built to house folks, but holding enough people to create critical mass so you could sustain it and sustain that population indefinitely, that's still beyond us. We might be able to stay underground for 20, 100, maybe 200 years, but right now we'd still be dead. So getting off the planet is a good point. We don't even really fully understand solar storms. At least one of the theories is that's how Mars lost its atmosphere, is during a particularly difficult solar storm that stripped the atmosphere off the planet. And the same thing could clearly happen here. In fact, there was some speculation, I think about 2 weeks ago, that the solar storm they were anticipating that was building on the sun could do significant damage if it in fact hit the Earth. We're still here, our electronics are still working, but every time that happens, there is a chance that we could take substantial damage, and that damage could be terminal for the race. So we want to sustain the race or extend the race. We do have to get off planet, but we're probably going to have to alter our biology to work to operate on another planet that is non-Earth-like. We were developed for this planet, so living on another planet would be problematic. We would have to fundamentally be different. Heavier gravity alone would require us to have a much shorter stature, might need to walk on 4 instead of 2 legs, and far more robust bones. There's a practice called scientific prototyping that the DoD uses, where they pull science fiction authors in, and the science fiction authors collectively forecast the future. Again, not really good with regard to timelines, but if you're thinking about things like, war in space, and we're working on that now, DoD, the Department of Defense has a program right now where they're going to use VR and the deep tanks to train Space Force so that they can fight in space. One of the big issues, however, is in deep tanks you're dealing with water and resistance, not to mention water pressure, which you're not going to be dealing with in space. And while VR will certainly be able to emulate how weapons will work in space, we don't have ray guns yet, so they're projectile weapons. And you've got a couple things that are a problem with choosing projectile weapons in space. One of them is you don't have air slowing the bullet down, so it goes much straighter. The other is every action results in an equal and opposite reaction, and that gun becomes a propulsion mechanism. And if you fired a military rifle on the moon, for instance, you would probably find yourself looking down at the moon from some altitude that would be relatively uncomfortable. Not to mention you'd be a flying target for whoever was shooting back. So that's why you've got to do training, but that doesn't happen in a deep tank. A deep tank, you've got heavy water. Any propulsion that goes out one side, you're just going to push against the water. On the other side, you are not going to go flying off into the water. It's a fire spear gun; it doesn't move you at all. So even emulating some of this stuff is very difficult for us right now. We can do it visually, but we're not really capable of doing physically. We would have to train in space, and so we've got a lot of issues. Now we've got to go. There's just no doubt in my mind we've got to go. My concerns are really that expectations are ahead of the science at the moment. We're spending way too much time on consumer level tourism efforts, which all it's going to take is one screw up, and it's going to set programs back decades. It's remember when Challenger went up, it pretty much killed the space program. And so we get a Blue Origin rocket that goes up and doesn't come down, and recognize that people that work at Blue Origin have gone on record saying there's no way in hell they'd go up in that thing, suggesting it is not the safest thing on the planet. And of course we've got Elon Musk with SpaceX. And if you've watched Elon Musk and what he's done with autonomous driving, it's like watching a kid run with scissors. And do you really want rockets going up with people in them run by a company who doesn't seem to understand how to mitigate risk? And so we've got issues. And the issues is we're not being as careful as we should be. The people that are driving the recent spurt in space travel are not exactly known for being either the most caring, careful, or prudent folks on the planet. And we have a nasty habit as a race of seeing a major accident and saying, yeah, we're not going to do that anymore. And so my concern is long before we get to space, we're going to scare the crap out of ourselves and keep us landborne. And if the races survive, like you pointed out, we kind of have to get off the planet, but we have to do it prudently. We have to look at the commercial benefits so it becomes self-funding. We need to get in-space manufacturing up and running so we can do a lot of these things affordably. And then we need to really return to this idea of using innovation in space and finding ways to apply that innovation on the planet, and really dial back the space tourism stuff. There is, to my knowledge, there is really no potential upside other than economic to this. And even on the economic side, those things aren't making money. It's pretty much all PR. All it's going to take is one screw up, and then wants to go to Mars when you saw 12 or so people splattered all over the pavement. So doing this, really thinking through the process, assuring success, and making sure the effort is focused on the preservation and advancement of the race, as opposed to PR stunts, in my view, would be a far better path forward than the one we're on.
Thank you. Professor David J. Kelly.
Well, so based on everyone's topics, or what everyone said, I'd have to say that I'm not a theist. While there is circumstantial evidence to support it, there's no empirical proof, and so admit it's possible, but there's not what I would call empirical proof. But to me, it's not really an operational detail that I can do anything with. So I tend to ignore it. In terms of us getting out of space, I think it's probably our single most important goal as humanity. We need to get off world, because otherwise at some point we're all going to die. And I disagree with Rob in terms of us being not careful enough. I mean, to me, the cost of a few human lives is worth getting there as quickly as possible. Whether they, it's the problem is, which I think Rob is right about, is that humanity or society, they see one death and they're all like, oh no, that's the end. And that's hogwash. People dying on the way there, I don't think should be a big deal. We need to get off planet sustainably. I like SpaceX's approach in that they're not using people. They just keep launching them. They blow up, no big deal. Let's get another one. But as long as there's no people, no one's going to have too much of a cow about it, and so they're probably fine. Whereas I think all of this commercial stuff where that Jeff Bezos's toy rocket doesn't even go into orbit. It's not a real, they're that's a risk, and it could damage the space program, which I think is more important than people getting joyrides out of space flight. I do think it's absolutely critical that we start by probably colonizing Mars. Although I think in the long run, we'll get more return on investment out of terraforming Venus. But that's like a much harder problem than terraforming Mars. Terraforming Mars would be pretty straightforward, but terraforming Venus, I'm not sure we're quite there yet to even intelligently talk about that. But yeah, we should get off world, do it as fast as possible, and like literally no other program that government does, from humanitarian support to the military, should come before space exploration, in my opinion. I'm not sure how much I can contribute to all that. My focus is on AI, so maybe my AI systems might help at some point. But yeah, if I could, that would be the number one thing I would be focused on is getting off world.
Thank you. Professor Ching, what is your summary for today's sessions and concluding remarks?
Okay. Well, our world needs to advance from the current money-oriented society to knowledge-oriented society. And my experience from the study of culture level quotient, another throughout history, culture changes from one area to another area. You cannot change the culture of a place. It's best to just create a new place where people with advanced culture will move to the new place. Such as the best example is today's America. You see, people move from all over the world to have with new ideas to create this new world in America. Okay, in Europe they're stuck with science. Okay, science is based on empirical verification, which I'm as the founder of pole science. I'm probably one of the most critical person of this one method. You know, my mentor is Paul Feyerabend. He wrote 2 books. One is Against Method. What method? The scientific method. Another book, Farewell to Reason. Okay, I don't believe reason controls us. I think culture controls us. So we need to move to a new world in order to create this knowledge-oriented society. The next new world, actually. How much knowledge do we have today? Okay. Today we are in a scientific age. Okay, science is just the beginning. Then what it shows us, science shows us there's existence of non-viable laws of nature. Okay, so that is a big contribution. Then we have to go to social science, we have to go to life science, we have to go to robotics, then we have to go to self-creation, then finally for me, it's fuzzy logic. Okay, which sort of look over everything, in its proper place. Again, this is just a baby step, just like Adam said. Okay. We're babies, in knowledge. I expected people to get to fuzzy logic, finally self-creating fuzzy logic in maybe 4,000 years. Okay, we're starting to do this. But there's far more knowledge waiting for us to develop to a stage we can do it. We can do something, for our survival, for the survival of the human race, or even for ourselves. Today we don't even know how to survive ourselves. I'm trying to help people to reduce age by epigenetic lifestyle, and I think I have demonstrated, and also I have enough theory to be more correct than most people. So Anthony can come over and take a look at what I have done, And all these kids, they follow me, they're going to live forever. They're going to live for a long time. Anthony,
I'm going to come to San Francisco.
Look young, you still have a chance. So this whole thing about knowledge, for one thing, the world, also I don't mean to really criticize, but Rob and David, they talk about the future. They talk about what we should do, but could we solve the problem of decision making first? The decision making should be based on valuation. The solution value. The solution value is posed by 2 Nobel Prize winners, Gerald de Boer and Kenneth Arrow, and it's being ignored by the entire society, and also possibly almost the entire economic community. What's going on? We are rejecting the most fundamental question in social science. So we resist to go into social science. Okay. And we need to make decisions whether we should go to Mars, whether we should go to Venus, we should, all this decision making. Okay. Also, how we treat the environment. Global warming, is it good or is it bad? Okay, eventually we're going to face ice age. So is global warming good or bad? Okay, we want to warm up the planet. We don't want to warm it with carbon dioxide. We want to warm it with a fusion reactor. Burn some, turn some matter into energy. Okay, without really polluting the air. Okay, so all these things, need decision making. Okay, and we don't have that. Okay. So we have about 20,000 years to take care of to learn to solve the environmental crisis, the climate crisis. Okay, which I think we might be able to do it. Okay. And we have millions of years to find a new space colony. Okay, that's roughly the only 2 things we seem to to have some kind of understanding. And well, again, we need to immediately we need to find the next new world. Okay, and the sheriff and I are try to debate which one will be the next new world. Okay, and we cannot do it in the U.S. U.S. has lots of it's based on the thinking of this guy John Locke, philosopher. His republicanism, okay, which rules the United States. So now you look at all this political struggle, going on. You think that maybe this is not the future for the next new world. China is even worse. China is is trapped in its old ancient culture. And Marxism. Marx doesn't know much about mathematics, so his idea, his vision is good, but he didn't solve any problems. So you need knowledge. Also, Europe is trapped in science, so that is old culture, basically, especially from the point of view of pole science. So we need to find a new word. That is the immediate practical, thinking. That possibly it would take like a World War II, some conflict in the northern hemisphere, then we move down to the southern hemisphere. But anyway, there's only one or two new world left to go to. So before that, we better get start to think about knowledge. Instead today's money-oriented society, all young kids, they're only interested in short-term and monetary return. Nobody think about long-term, except Anthony and Rob and David and people here are thinking long-term. Okay, we are the top guys on earth. So that's my conclusion. I really thank you all contribute to the future.
Thank you.
Right, I'm going to try and squeeze in as much as I can in a very short time, just to mention a few other bits. Going back to Mars. Once we create domes on Mars, through a central fugal force, we can simulate an Earth-like gravity. So we can overcome that problem like that through a central fugal force. Obviously, as Rob mentioned, there are going to be changes to the body as we adapt in a new environment to a weaker gravitational field and so forth. So there are going to be it's a time of adapting and so on. So this is obviously something very important to note. Also, we could use robotics. Now, David Kelly, artificial intelligence to do the in quotes guinea pig work at the early stages of colonizing and terraforming Mars. Because of the radiation, as I said, because it lacks a magnetosphere, as a result of the slowing of its magnetic core, its iron core, it was stripped out. Magnetic field was stripped out. So it has no magnetic field. It's subjected to enormous amounts of cosmic radiation, gamma rays, ultraviolet light, and so forth from supernova, pulsars, and neutron stars. Enormous amounts of radiation, highly energetic particles. So we could have AI doing the work for us on Mars, robotics. So this is where robotics would come in at this stage. In terms of introducing algae, importation of algae to Mars, algae breaks down carbon dioxide and produces oxygen. It also absorbs enormous amounts of sunlight, means that you reduce the planet's albedo by maximizing sunlight absorption, just like you would with the orbital mirrors. You would maximize sunlight absorption, reducing the planet's albedo, the amount of sunlight reflected back out into space. So algae would absorb enormous amounts of sunlight, reducing the planet's albedo and breaking down carbon dioxide and generating oxygen. So these are some of the ways around that. In terms of the golden moons of Jupiter, this is now really science fiction. And again, I'll just mention this very quickly. Take Europa. Europa is a ball of frozen liquid in hydrothermal vents. Now, one of the ways to terraform Europa, for example, would be, again, nuclear detonators, again, orbital mirrors, maximizing sunlight absorption would be one of the ways, and redirecting comets and asteroids to strike into its surface. What would happen over time? You sublimate the ice. What you would get basically is the ice would melt. You would create enormous amounts of water vapor, an atmosphere of water vapor. As the water vapor interacts with Jupiter's magnetic field, you would undergo radiolysis, and you would produce oxygen and hydrogen. Hydrogen would be lost to outer space, and oxygen would remain. At the same time, you would be releasing enormous amounts of greenhouse gases, ammonia, methane, and this would help terraform the planet. Terraform the moon. It would help terraform the moon. Okay, so these are one of the ways that you could actually go about terraforming, for example, Europa. Incidentally, you would have a water world, so it would require floating settlements. And we believe that the ocean, going back to what Alex was saying, the ocean could actually contain organic molecules and life and so forth. So basically, again, with Europa, maximizing sunlight absorption as a result of orbital mirrors, redirecting asteroids and comets to strike into its surface, and so forth. Over time, you sublimate the ice, you melt the ice, create water vapor, an atmosphere of water vapor. As it interacts with Jupiter's magnetic field, it undergoes radiolysis, you produce oxygen and hydrogen. Hydrogen is released into outer space, and oxygen remains. But these are some of the techniques. Of course, this is a very complex, convoluted process. We're talking about an enormous distance between Earth and the Jovian system. So this is really science fiction. I've written about this. This is something, obviously, that remains only science fiction at this stage. As I said, Mars is the most terraformable planet at the moment. Now, going back to the whole notion of God and the whole notion of nothing. Well, even nothing is something. In fact, nothing is a physical concept because it's the absence of something, and something is a physical concept. So there is no such thing as nothing. Now, we now know through quantum mechanics and through the Hadron Collider that the universe is a giant cosmic superconductor. It's a giant cosmic superconductor. There's an invisible field everywhere in the universe, and this invisible world defines and represents all of reality. Okay, but that doesn't mean that God doesn't exist. God is operating through the quantum world. Lawrence Krauss and Richard Dawkins will say, if you wait long enough, you are guaranteed by the laws of quantum mechanics to produce something out of seemingly nothing. Out of seemingly nothing, because every single point in space contains information. There's an invisible field everywhere in the universe. Every single point in space contains information. So if you wait long enough, you are guaranteed by the laws of quantum mechanics to produce particles, matter, and then a universe full of stuff. But the trouble here is physical laws do not create physical realities. So they basically, if you're saying this, you're ascribing creative power to physical laws. Physical laws do not create physical realities. Well, cellular mechanics operates under certain laws in physics, but those laws didn't bring the sun into existence. Agency is one thing, creator is another. You see the problem. So what they say is if you wait long enough, by the laws of quantum mechanics alone, you will produce a universe out of seemingly nothing, because energy produces positive and negative energy configurations. As a result of producing positive and negative energy configurations, you can produce a universe out of seemingly nothing. But it's impossible because physical laws do not create physical realities. So even within the world of quantum mechanics, God is operating through quantum mechanics and creates all of reality through this process. So this is the problem with atheism, you see. In fact, God uses order out of chaos. If you look at what we're made up of neutrons. We're made up of many particles, but the particle that we are predominantly made up of is a neutron. A neutron is radioactive, and it decays within 10 minutes. This is known as weak decay, because within particle physics units, 10 minutes is considered a very long period of time. In the classical world, a very short period of time. So you have the relativity of time at play here. So basically, we are made up of neutrons, many neutrons that decay within 10 minutes. So how is it that we exist? Order out of chaos. Once you place a neutron into a nucleus, it becomes bound. It loses energy. If we use the formula E equals mc squared, as it loses energy, it loses mass. It loses so much mass that it can no longer decay within the nucleus. And this is why we exist. Carbon, nitrogen, oxygen, everything exists because of this process. Incidentally, because of the first law of thermodynamics, when a neutron decays, its energy is never lost because of the first law of thermodynamics. It becomes a proton, electron, and neutrino. But once housed within the nucleus, it can no longer decay. Thus, it doesn't become a proton, electron, or neutrino. It stabilizes within the atomic nuclei. And that's the reason why we exist. This complicated process within nuclear physics. And I'll just finish with this. The atom that lacks an electron creates life. The atom that lacks an electron creates life. Order out of chaos. As a result of this, covalent bonds are formed. DNA, RNA, and molecules are formed as a result of a deficiency at an atomic level. The atom that lacks an electron creates life. This stable atom doesn't do anything, which philosophically implies that the whole notion of perfection is nothing but a construct of the mind. Right, I could go on and on and on and on, but going back I'm going to jump back now to Europa. Incidentally, Europa, Ganymede, and Callisto are the three most terraformable moons. Ganymede, Europa, and Callisto are the most terraformable moons of Jupiter. Callisto is the furthest one out, and it receives very little radiation, 0.01 rem of radiation. So that's well within human tolerance. But Ganymede, Ganymede and Europa, if terraformed, you would have basically 3 water worlds. And Ganymede and Europa would have problems in terms of radiation. So you would probably have to have some sort of radiation shields going around these moons. But anyway, I don't have much time, so I'm going to thank you very much, and I'll pass to Rob.
Thank you, Professor Rob.
Yeah. Okay. So space exploration. Let me pivot a bit from my concern with regard to focusing too much on the fun aspects of space and not focusing enough on the critical aspects to the Fermi paradox, which, interestingly enough, was neither a paradox nor was it from Fermi, but we won't go into that. The underlying concept is mathematically there should be a lot of life in the universe, and we haven't been able to detect it. Now, odds on, the chances is we just don't have the tools to detect it, or the intelligence we're trying to detect is so different from our own we can't sense it. It's a detection problem, not necessarily a life existence problem. But the concern really comes down to some of the theories as to why we can't detect it. One of them is that the reason we don't detect it is because all the other intelligent life is either dead or it's hiding. And the reason it could be dead is because at a certain level of technological advancement, there is a higher probability that the life will destroy itself. And we've certainly seen that here. We have developed the capability of destroying the planet, not just with nuclear weapons. When the Hadron Collider came up, there was a very real concern that it would create a black hole, and the black hole would consume the planet. And since it's the only place we got, consuming the planet would be problematic. Now, the odds of doing that were exceedingly remote. A problem is the mathematics that were used to calculate those odds were flawed, and they were 2 magnitudes off in the wrong direction. Now, we're still here. We're not dead. But my personal view is, if you're going to do experiments that could consume the planet, maybe you ought to be doing those experiments off planet. Because once again, if you make a mistake, it's not like we're capable of moving at the moment. It's certainly not, and even with the science, we're not capable of moving fast. And so doing things that harm the planet before we can get off the planet would seem to be less than self-serving. And it wouldn't even have to be a mistake like a nuclear war or a Terminator-like event where AIs go crazy. We're seeing with global climate change, we are aggressively changing the environment of the planet so that we can't live here, and we cannot get off it yet. So the focus right now, because the science doesn't let us get off the planet in mass, much of the focus should be on making sure we don't have to get off the planet in mass. Using some of the technology to protect against things we know could harm the planet. Solar storms, we don't have great protections against solar storms. Even the hardening we do on our electronics isn't sufficient. Military, and we can harden. Military hardening will hold up to a solar storm, since it was designed to hold up to a nuclear war. But we don't do that kind of hardening on our electronics and our grid, our cars, our appliances, our tractors, all the things that make living on this planet possible, that are electronic and mechanical, are vulnerable to a major solar event. Should it hit the planet, even the atmosphere stayed, we could be in a world of hurt after a major solar event if we lost a major component of our electronics. Yes, we could rebuild, but the time that we're taking to rebuild, we wouldn't be able to move food around, we wouldn't be able to harvest. Or if we did harvest, we'd have to go back to using oxen and other forms of labor that we had before we had tractors. And we're not even remotely equipped to fall back that way. Some parts of the nation could, but the world could not. So in the end, space exploration, I think right now has kind of the wrong priorities. A lot of the effort seems to be, hey, let's see what we can do in space that's fun. And really, a lot of the effort right now should be let's see what we can do in space to assure that we continue as a race. Let's see if we can first preserve the planet so we don't have to get off quick by our own cause as opposed to external cause. And that would include better shielding the planet from external events, asteroids, solar storms, and now more recently from a hostile state that was using a military platform in outer space. China wants to build a military base on the moon. Not a good idea, really, for the other nations on the planet. So the move to Mars would make a ton more sense if we could figure out what beneficial we could do there. It is not, as Anthony points out, the best place to try to live. I've seen some arguments that argue that Venus might be better because at least it has an atmosphere, and some of the problems you trade off with Venus and Mars might be easier to solve because of that atmosphere. You can, for instance, you can lower stuff into the atmosphere far more cheaply than you can at Mars at the moment, and because of the atmosphere, your level of atmospheric shielding can be reduced. But be that the case, and we could certainly build facilities in space to hold a portion of the population, but much like building a facility deep in the earth, getting the size of population that you need to make it sustainable would be problematic. So goal number one would be to make sure we don't have to leave before we're ready. And then goal number two is to find a place to go, and then to make sure that we have, if something happened to the planet, had a sustainable critical mass of resources that were out there. And then finally, we really kind of do need to understand, why aren't we able to detect life? I mean, a lot of theories, a lot of them good, and my own belief is it's out there, we just haven't been able to detect it. But belief does not mean reality. We really do kind of need to know, why can't we detect life? Is there something about the universe that we don't know about that we should be protecting against? And certainly should be doing that a bit before we go out there, before we go out and start sending messages into space saying, hey, we're here, come visit. Because who knows what the hell we're telling we're here. Now, to be fair, and I don't want to scare anybody, the science fiction ideas that aliens are going to come to the planet, harvest our resources, are kind of foolish. Anything that we've got is much more readily available in other parts of even our solar system. Water, there was some early theories that they come here and take our water. Yeah, water is really prevalent in the universe. They could get it much cheaper and easier someplace else, and we polluted the crap out of ours, so why would you want it? So the idea of a group coming in to take over the planet and steal our resources is probably damned remote. On the other hand, the idea that there might be a race out there that was incredibly territorial and might view any other intelligent race as a rival, and have the belief that they need to eliminate that other intelligent race to protect their own, is not a stretch at all, because we operate that way. And it's hard to put aside how we operate when we assume how others operate. Now, chances are they don't, but when we're talking about almost unlimited space, and unlimited variance, there is a reasonable chance that there's at least one powerful race that does, and being introduced to that race before we're ready to protect ourselves could certainly be catastrophic. And so it still goes back into, okay, understanding the risks and then proceeding safely forward, so in the process of solving a problem, we don't create another larger, more dire problem. As mentioned, I'm not against space exploration, not by any sense of the imagination. I'm for doing it safely, doing it in a very focused fashion, focusing on the commercial benefits of the overall effort and the learning efforts of the effort going forward. Hugh made some good comments about decision making and the fact we do it very poorly. In a previous show that we did with a different group of folks, I was on it, but none of the others, I don't think, were on it. We argued about using AI as a way to create a hierarchy. When you've got a collaborative group of people going together, there is a tendency for the loudest voice in the room to win the day, as opposed to the person that was most informed and most well-grounded in facts. It was our collective belief that you could use a combination of blockchain and AI to create a decision hierarchy so that people that didn't know what they were talking about were effectively downvoted, and people that were an expert on whatever the individual topic was upvoted, creating a higher probability that the consensus opinion would be the right opinion, as opposed to the opinion that came from the person that had the loudest voice, which is problematic as we look at the current space situation. Bezos and Musk clearly have the loudest voices at the moment, and neither one of them are known for a focus on safety as they proceed. Musk, in particular, seems to be a guy that just seems to be hell bent on destroying himself, and that would be far less of a concern if it wasn't the fact that one of his companies is throwing relatively heavy explosive items into space, and Bezos' space program is still has not been shown to be viable for anything other than lifting up people, as I think David pointed out, not even into low orbit. But if that damn thing comes down in a populated area or comes down with a bunch of celebrities, it's going to set back everything a substantial amount, and for a bad reason, because what Bezos is doing is not what NASA's doing. It's not even what China's doing. And bringing up China is so hell-bent on militarizing space right now that they themselves may become an existential threat to the planet. Because imagine what would happen if they were be able to establish a critical mass of nuclear weapons on the moon. They could hold the planet hostage. I mean, Russia is currently holding the planet hostage with domestic-based missiles with regard to Ukraine, and we certainly wouldn't want that at a global level unless you really like the Chinese government and you like that form of living. I'm not a fan. And of course, that for China, once they did that, space exploration would pretty much be done, because China isn't really an exploring entity. There's not much they do with exploration. They expect with regard to commercial focus, and as I mentioned, much of their space focus is on militarization, not exploration, and that would really be a wrong initial focus to take in going to space. So a global effort to assure that space exploration was focused on the advancement of the race, focused on protecting against predictable events that could wipe out the planet or the people on it, and to assure that there's a decision-making process having to do with all of this, where the people that are the most informed are the ones that win the day, not the people that have the most money, or the people that have the loudest voice, or the people that are most influential. This is a critical aspect of whether or not we continue as a race or whether we don't. And that means that the people making these decisions need to be the best we can find and not the loudest.
Thank you, sir. Professor David Tricali, what is your concluding remarks for today's session?
Well, I don't know. There's a number of things I guess I would like to say. In terms of livable environments, Io and Venus actually have more livable environments for what we need as a species than Mars. Now, at Venus, for example, you can't live on the surface, really. It's like 800 degrees, but about 50 miles up, where it's about one standard atmospheric pressure, you could live in a blimp indefinitely, and all you'd need to go outside is a oxygen mask. And Io already has liquid oceans in it. You just have to drill through the mile or couple miles of ice or whatever it is to get to it, and it would be salt water like the ocean. You can't breathe salt water very well, but certainly could put a submarine down there and live in that. So I think those two in particular would be, if we're just looking for a colony off world as easy as possible, those probably would be the two best locations that are quote unquote the safest. Whereas Mars, you have to deal with a number of other issues. But in terms of terraforming, it certainly seems to be the easiest. In terms of decision making, a part of the problem is there is no way you're going to get society to buy off on any one particular methodology. It's just not even tenable to even consider it. And that's why, in my opinion, it's better to just focus on space exploration. It would be better to get 1,000 people sustainable on Mars than to fight global warming, or trying to feed starving people, as cold as that may seem. As a species, I think it's better to get off world and put that as a higher priority than just about anything. I mean, there is no project that the government does that I know of that I would put ahead of off-world colonization. There is something to be said by doing it safely, and certainly, as a species, one would hope that we're responsible enough to take care of our home world. But that's going to be a long fight because not everyone is participating, and everyone, people and companies undermine what we would want to do with our home world, which is hugely problematic. And I don't see how we can force them in any practical sense. We've made it cool, so there's a lot of peer pressure, and I think we're making progress in that direction, but it's still just terribly weak in terms of what we're doing to save the planet, in my opinion. And that's why I think, because you only need a smaller amount of people to buy off on the idea, colonizing Mars is an easier problem than solving global warming, just because of all the people that are pedaling in the opposite direction, metaphorically. That said, I mean, it's just disgraceful in my mind what humanity has done to the planet, and I'd love to see it saved. It's just not. I just don't see that it's entirely tenable as much as we would hope, and it'll take quite a few generations, I think, to recover from what we've done on the planet. For me, I think that going back to the whole decision-making thing, it really is about, for me, it's about SSIVA theory in terms of decision-making. I don't, the philosophy and the soft sciences really are not empirical enough for me, and I don't really want to debate philosophy. It's, for me, it's logic and more logic, and not so much philosophy. And SSIVA theory, I think, provides the most coldly logical way of applying ethics and morals, and so I tend to use that in decision making, and trying to get everyone. And that's another thing with getting humanity to do better decision making. Awesome goal, but everyone's again pedaling in the opposite direction from each other. So trying to get everyone on the same page in terms of being more mature as a species is just virtually impossible. At least from my standpoint, it seems like it's virtually impossible. In any case, I'll do my best to support, colonizing off world, and in my little way, mainly with AI, and Actually, I'm into closed biosystems too, which you can probably see kind of by my computer here. There's a big, huge vivarium that I use as a Kanban board, but those two areas I try to contribute to our learning, and we'll see what happens.
Thank you. Thank you. This is really excellent discussion, especially for our audience. We're just finishing our 619 episodes. So we have more interesting discussion tomorrow for quantum computing. We have debate uh, as we are working in developing nations. So hopefully all of our dialogues and debate will be very helpful for the developing nations youth. Thank you everyone for joining today's session. Thank you. Bye-bye and take care.
Okay, bye-bye.
Bye bye.
Hey, Bob and
Okay,
Anthony.
guys. Thank you.
Also.
Ciao.
Thank you.
Yeah.
Bye bye.